Hello everyone, this is Matthew Wood. I'm part of Team 7, which is developing the BioNomo product. One common problem among college campuses, and specifically at Virginia Tech, is body odor. Whether it's due to a lack of time or commitment to personal hygiene, many students find it's hard to create time in their schedules to really focus on their body odor. This has many social implications for whether you're going out or going to class, so it's an important issue for college students to address. We identified this and decided from our personal perspectives on the issue, as well as surveys from customers, that to best meet the customer needs, our product needs to be easy and quick to use, and also comparable to already existing cologne bottles, since we aren't necessarily trying to completely replace those. It should be also small and portable, something that you can bring in your backpack and carry with you around campus, since we are marketing this toward college students. Now, the product actually has to take energy and material in and release it out of the system. First, the energy going into the system comes from either manual input or electrical input to actually push the fluid through the system. And then energy is then dispensed from the system through kinetic energy when it's exited through the nozzle. Next, the material is obviously going to be the cologne inside of the system. The material is pushed into the system through either a cartridge or a different reservoir of cologne, and it's then, like the energy, exited through the nozzle of the device. Now, we did an exercise called the gallery method, where we identified some sub-criterion that helped us understand how the product should actually function to meet our customer needs. From this, we got feedback that said that we needed more clear sketches to better identify how, like, for instance, a manual pump would be, how a manual pump would be included in a solution. So with that knowledge, we were able to adjust our gallery method poster and some of our sketches ultimately to best reflect these feedback. So generally, our three sub-functions are going to be the structure, how the cologne is actually applied, and the power input, or the power source for the cologne to get pushed through. So for instance, many current cologne bottles are handheld, so we obviously have some solutions that are also handheld to kind of replicate this. In addition to this, we do have a wall-mounted solution as well as a freestanding, and one that hangs from either a ceiling or a door frame. And now, in the way in which the cologne is applied, one way would be through a manual pump, where the fluid is pumped through by either squeezing a trigger or pressing down on something. Or you have an electric pump that has a motor that runs the fluid through, more automated. Also, there's a roller option, although we didn't actually end up using this in any of our solutions. Lastly, the power source could either be a mechanical option similar to that of the manual pump, but also you could plug it into the wall or use batteries if it does use electrical power. And from these, we were able to combine these concepts and develop 6 unique solutions to this problem. The first of which is the tower solution. As seen in the figure, the cologne bottle moves up and down along a shaft, as well as having a spring that pushes it up and down at different heights. So at different heights, it can spray at different locations along your torso. Next is the squirt gun solution. So we basically modified a pre-existing product, which is a squirt gun, and instead of using water inside, we replace it with cologne. And also, instead of a typical nozzle where it shoots out in a straight line, we have a twist nozzle that allows for different shapes of cologne to come out to give different sprays and give the user more options for how much they want dispensed. The next one is a nozzle solution, which is fairly similar to the squirt gun in that you are pressing down on it to dispense the cologne, but it has multiple cologne cartridges, so you have different scents and options to spray with all in one. In addition to this, the fluid is pumped through and exited through the twistable nozzle that, similar to the squirt gun, controls the shape and amount of cologne dispensed at each pull of the trigger. Our next solution was the 2-axis wall mount. In this, a system is attached to the wall, and it can move it both horizontally and vertically to spray different parts of your body. This would also have a sensor to detect which parts of the body it needs to spray and what location it needs to correspond to actually reach that position. Similar to this is a ball and socket solution, where instead of moving in only 2 directions, this can move in 3 dimensions. So the ball and socket allows it to freely rotate, but also have enough stability so that it stays in place. But similar to the 2-axis wall mount, it would have a sensor on top to best locate where it should spray. Next is the door string solution, where if you really want a product that doesn't take a lot of energy or time to use, this will be it for you. You could activate this by simply opening a door and having the cologne spray on you, whether it's you leaving your room for the day or maybe you get out of the shower and you leave the restroom, the cologne sprays on you from you just opening the door. Now, from these 6 solutions, the team had to actually choose which one we're going to move forward with. And to do this, we started by screening each of the 6 options. We chose the 2-axis wall mount as our reference solution because it seemed kind of like a middle-of-the-road solution that could be developed, but we could also see other solutions that might outplay it. And we verified this by doing the screening. So, for instance, a plus would mean that for a certain criteria, for instance, the ease of use, the squirt gun would be a better solution than the 2-axis wall mount, since a squirt gun doesn't take as much time and energy to set up as a 2-axis wall mount would. Using the same logic, a 0 would mean that it's basically equivalent to the value of the 2-axis wall mount, and a positive would mean it's better, a negative would mean it's worse. And now from summing the zeros, pluses, and minuses, we determined that the squirt gun, 2-axis wall mount, and the nozzle were the 3 solutions that we would go ahead and score. Now for scoring, we specified a little bit more of how each criteria was going to be weighted. So for instance, we determined that the ease of use of the product was more important than the aesthetics of it. And another change in the scoring versus the screening is that we had different references for different criteria, since the team felt that, for example, the automation best fit the baseline for the nozzle, whereas the ease of use best was the median for the squirt gun. So the team multiplied the weight times the rating to get the score, and added the scores up to determine that the nozzle had the highest score, thus making it the winner of the screen. Now, one thing to note is that although the nozzle was chosen, it did have it was determined that it would be the easiest to use, it would deliver a consistent and accurate spray, and would best deliver a chosen mount because of the nozzle feature on it. And while many of the other options would be viable and would be very interesting to develop, it would often be in the case that it would be outside the scope of the class. Like for example, the 2-axis wall mount would be too expensive both for us to develop and for the customer to buy. So for those reasons, it just made the most sense for the team to go ahead and choose the nozzle as our final solution. The team made CAD models for this solution. We included everything we showed in previous drawings. So in the figure on the left, we see that there are different cartridges that can be twisted around, so different scents can be pushed through the nozzle. And on the figure on the right, it shows how the pump actually works. You press down and it pushes fluid up and through the bottom hole in the nozzle. And as seen in the figure on the left, the nozzle can be twisted so that different shapes can be selected, thus allowing different sprays. So with that said, thank you so much for your time and for listening. The team is excited and looks forward to further developing this project. And as changes are made, they will soon be reflected in future design phase reports and presentations. Thank you again for your time.